Hello friends, uh, today I am going to show you and present the components about used in 400 kV switchgears. I will basically explain the circuit breaker which is mostly used in 400 kV switchgears. So let us see first which scheme is used in 400 kV switchgear. As we know, there are widely two schemes which are used. First one is double bus bar arrangement, and the second one, which is mostly and commonly used in 400 kV switchyard, is one and a half circuit breaker scheme. So we should know what is the benefit of one and a half circuit breaker scheme. If you look into one and a half circuit breaker scheme, we will observe that there are many advantages of this scheme as compared to double bus bar arrangement. The first benefit of this scheme is cost is less compared to two main and transfer bus scheme. Second is either bus may be taken out anytime without loss of service to the feeder. Maintenance of more than one breaker is possible without any loss of service. In this system, no isolator operation is required for changing over from one bus to other, as all three breakers remain closed during normal operation. So here we don't require any operation of isolators for changing over the bus, because in one and half circuit breaker scheme there are three breakers and all the three breakers are normally closed. The third advantage and the most important advantage of this scheme is in case of bus fault, power supply to the connected feeders continue from the other bus. So there is no interruption to the power supply of the loads. Next, we see that the components used in 400 kV switchyards may be explained like this way. First one, and the important equipment. I should not say important equipment, as all the equipments in a power system are important, and loss of any equipment will affect the availability and stability of the power system. So all the equipments are equally important. So the main components used in 400 kV switchyards are circuit breaker, disconnect switch or isolators, current transformer, electromagnetic potential transformer, normally known as potential transformer only, capacitive voltage transformer means CVT, lightning arrestor means LA, grounding switch, or some people say it earth switch, and power line carrier communication. So we will focus only circuit breaker in this session, because I would like to mention here that the circuit breaker used in 400 kV switchgear had some interesting point if you compare it with the circuit breaker used in 220 kV switchgear. So next we see how how 400 kV circuit breakers are important, and it have some interesting points. So first we will see about isolators, because the isolator used in 400 kV switchgear is not different, but still I am showing you. The isolator used in 400 kV switchgear is horizontal type and center post double break isolator. Center post isolator has normally three insulator poles over which disconnect switch is mounted. The isolator is motor operated, and it can be operated manually also. There is a provision given in it. Now we will jump to circuit breaker. There are two types of circuit breaker used in 400 kV switchgears, and they differ only in one feature, and that feature is the presence of pre-insertion register, commonly known as PIR. So a set of circuit breaker will have PIR, whereas another set of circuit breaker will not have PIR in 400 kV switchgear. Next question is arises, how will we use circuit breaker having PIR and which do not have PIR? So I will mention here that the circuit breaker which is used in the line side of 400 kV switchgear are having PIR, and the circuit breaker which is not used in the line side, rather it is in the side of generating source, then it will not have PIR. I will explain what is the purpose of PIR, but first let me explain some other feature of circuit breaker. Both the type of circuit breakers are self-compensating type. Now the question arises, what does it mean by self-compensating type? The word self-compensating type, if used in circuit breaker, means that the arcing energy is used to extinguish the arc. That is why we say it self-compensating. Mind that the arcing energy is used to extinguish the arc, so it's self-compensating. Mostly the circuit breaker used in 400 kV switchyard are a spring to open and a spring to close type, but it may not happen in all cases. Some circuit breaker used in 400 kV switchyard is hydraulically operated, but I am just telling you one case which is used mostly in modern power system. The quenching medium in these circuit breakers are SF6 gas, and the normal pressure of SF6 gas is 6 bar gauge pressure. Next it comes to components of circuit breaker. So a circuit breaker consists of following one parts. Number 1, pole column filled with SF6 gas, control cubicle unit, interrupter unit, base, operating mechanism cubicle, switching position indicator, post insulator, and grading capacitor. Now we will look one by one to each of the components. So this is a pictorial view of the circuit breaker used in 400 kV switchyard. Point 21 is bell crank mechanism. 22 is interrupter unit. So you see there are two interrupter units, one in the right side and another one in the left side. 16 is post insulator, 11 is base, and 15.1 is operating mechanism cubicle. This is a pictorial view of grading capacitor. 23 is grading capacitor, 23.1 is inner bracket, and 23.2 is outer bracket. Next it comes the purpose of PIR. PIR stands for pre-insertion resistor, and it is connected in parallel to the contacts of the circuit breaker, and its value ranges in between 200 to 400 ohms, which gets temporarily closed before closing the circuit breaker. The sequence will be, first we will close PIR for 10 to 12 milliseconds, then we will close the circuit breaker. Once the circuit breaker is closed, most of the current, not most of the, almost all the current will flow through the circuit breaker contacts. So PIR should open. Now the question arises, what will happen if PIR do not open? So the answer to this question is that if PIR do not open, then a small current will flow through the PIR when the contacts of circuit breaker is closed. So its heating will result. Also, when the circuit breaker is opened, PIR is still closed. So current will flow through the PIR and it will get lost. So it should be ensured that PIR has opened after the closure of the circuit breaker. This is very important point. So bear it in your mind clearly. Next it comes to purpose of grading capacitor. As we all know, grading capacitors are used to equalize voltage over the insulator ring. Here also the purpose of grading capacitor is same, to equalize the voltage across the contacts when the circuit breaker is open. Now I am asking you one question. Why did we use multi-interrupter circuit breaker in 400 kV switchgear, not single break circuit breaker in 400 kV switchgear? This is very interesting question and it will reveal some important points also. The answer to this question is that by using multi-break, let's suppose double break circuit breaker, we are dividing the whole 400 kV into two parts, two equal parts. How we are dividing the 400 kilovolt into two equal parts? The answer is simple, by using grading capacitor. As the grading capacitor equalizes the voltage across each contact, so the voltage across each contact will be 200 kV and 200 kV individually. So the pressure of SF6 gas needed to quench the arc will be same as that is used in 220 kV switchgear. As I mentioned earlier, mostly the pressure of SF6 gas in 400 kV circuit breaker is 6 bar, which is also the pressure of the circuit breaker used in 220 kV switchgear. So this is the answer. If you go to higher level of voltages, you will use multi-break circuit breaker. So that was about the circuit breaker used in 400 kV switchgear. Now it comes to lockouts provided in 400 kV circuit breaker. There are three types of lockouts provided in 400 kV switchgear, 400 kV circuit breaker. Number one, a general lockout. A general lockout prevents switching of circuit breaker if SF6 pressure is too low. Why this lockout has been provided? This lockout has been provided because if the SF6 gas pressure is low, its dielectric strength will be low. So arc quenching will not be possible and it may cause the damage to circuit breaker. Next it comes to the closing lockout. The closing lockout prevents the circuit breaker from being switched on while the closing spring is being charged. Next it comes to anti-pumping device of the circuit breaker. The anti-pumping device of the circuit breaker pole ensures that there is not repeatedly operation of circuit breaker like open and close in the event of simultaneous close and open commands. So this is what I wanted to share about the circuit breaker used in 400 kV switchgear. So if you like this presentation, please like this video and share this video, and don't forget to subscribe as I will update and share more videos here. Thank you.